Our lesson for today will be looking at chemistry 1502. Today's topic will be looking at alkene reaction. We are still busy with part 2. The reaction for today is hydroboration. Lesson 106. Let us start. This will definitely be the shortest, easiest reaction of alkenes because it is straightforward and it doesn't require close details like other reactions. So hydroboration of alkenes. This reaction, what does it yield? What is the purpose of this reaction? Now, the past two lessons we've looked at the hydration of alkenes, how to hydrate alkenes, how to add water to alkenes to form alcohols. And the two last lessons, or the hydration that we've covered so far, they follow the Markovnikov orientation. Now, what if we want to convert an alkene to be an alcohol, but to follow the anti-Markovnikov alcohol or anti-Markovnikov orientation? We use hydroboration. So hydroboration is one of the hydrating processes of alkenes to form alcohols, but the difference is we have the anti-Markovnikov orientation as our major product. So far it was possible for the hydration to take place under actually to yield a Markovnikov orientation, but the anti-Markovnikov was almost impossible. It was actually impossible until it was discovered that if we use diborane is actually B2H6, then if we summarize this, actually if we break this down, we actually have BH3, which we call this borane. We have two of them. That is why we say diborane. We add diborane onto an alkene to yield an anti-Markovnikov orientation. But the product becomes an alkyl boranes, and then we further oxidize to give an anti-Markovnikov alcohol. So we start by adding diborane to form alkyl boranes, and then we oxidize further to give alcohols, which will be anti-Markovnikov orientation. We'll have an anti-Markovnikov orientation. But before we look at the reaction, you should know that diborane, it's actually not a good reagent. It is toxic. It is explosive. We cannot really handle it and react it with alkene. So what happened is that we've tampered with diborane in order for it to be suitable for this reaction, to be handled and be able to react with the alkenes. So what happened is that we use a tetrahydrofuran, which is a cyclic ether, together with diborane. It doesn't go alone, but we use this cyclic ether together with diborane to react with alkene. So a tetrahydrofuran, we normally use THF to abbreviate this cyclic ether. It is actually like this, and then it has oxygen, and then when you react this with diborane, we are going to yield two of this, because remember that one borane will react with one tetrahydrofuran. This is partially negative. It's actually negative. and then this one is positive, it's partially positive. Then the two will actually neutralize each other, and then we have actually represented using this man. So we actually call this a borane, and normally we use to write it in this man. It's a reagent that we use to add on the double bond of an alkene to give an alkyl borane. And then after yielding an alkyl borane, we use hydrogen peroxide to oxidize the alkyl borane to form an alcohol. So we can see in contrast, hydroboration oxidation converts alkenes to alcohols by adding water across the double bond, and the product will follow the anti-Markovnikov orientation. So like I said, we have oxymercuration, demercuration. We also have the hydration, acid catalyzed hydration of alkenes, which we hydrate, we add water to form alcohols, and the products are Markovnikov orientated. Now if we want to hydrate, if we want to convert alkenes to alcohols, whereby we yield an anti-Markovnikov product, we can use the hydroboration oxidation. Now let us look at examples and how we can easily represent this mechanism or this reaction. So we have our double bond, actually our alkene. We react this with borane, it's BH3, the presence of tetrahydrofuran. Then this will yield you can see what actually happens here. I don't know if you can see the new parts of this molecule. What happened is that we've added hydrogen to this carbon, and we can actually, let us write it like this, hydrogen BH2. You can see it's the very same thing. This hydrogen will go to the most substituted. Should it happen that we have an unsymmetrical alkene, this hydrogen will go to the most substituted carbon, and then this part will go to the less substituted. So in this case, since we have a symmetrical alkene, we can add it to any carbon, it's fine. So you can see that this part, it is attached to this carbon, and then this part to this carbon. And then we have to continue to oxidize. Remember that we want an alcohol, so we are going to use hydrogen peroxide, and then this will actually form an alcohol. And you should know that we don't have any rearrangement in this particular reaction. So let us look at an example. I normally want to use, but let us use, I don't want a symmetrical. Let's use this. Okay, let us put another methyl here. Then the double bond, let us put it here. So we react this. We are going to use a borane, and then for the second reaction we are going to use sodium hydroxide together with a peroxide, H2O2, hydrogen peroxide. This will actually follow the anti-Markovnikov orientation. So the first reaction will be this one will be the second reaction. So let us look at our carbons, we can see that this one is the most substituted, this one is the least substituted. So looking at our B, it's actually BH2, then here we have hydrogen. This hydrogen will attach to the most substituted. So we have hydrogen here, and then our BH2 will be here. And then from here we look at the second reaction with peroxide. We actually need this OH in order to form an alcohol. So we are going to have something like this. And you can see that it follows the anti-Markovnikov with no rearrangement. We don't form any carbocation ions, so we cannot talk about the rearrangements. So as usual, we have the activity for today. The question is, predict the major product of the following reactions. So we have propene reacting with let's say it's BH3 THF. That is the first reaction. The second reaction, we have H2O2 OH minus. The second one, let's see, we have 2-methyl. It's 2-methyl pentene, pent2 in. I'm reacting with the very same reagent. Number 3, we have 1-methyl cyclohexene. Cyclohexene are reacting with the very same reagent. You can write down the answers in a form of, I actually need, you separate the two reactions. Reaction number 1 should show the product, and you put the arrow to continue with reaction number 2. That's it for this lesson video. This is Fahula SJ. Thank you very much.